Have you ever wondered how apps like WhatsApp, Instagram, or Spotify are built? They are made they are not made using loops, variables, or functions. They are built using object-oriented programming or OOP. So the programming paradigm that powers most modern software. In this episode, you will learn how to think like a professional developer. We will cover classes, objects, constructor, encapsulation, inheritance, polymorphism, and much more through real-life analogies. So, if you have completed the previous 14 episodes, you are now ready for the most important milestone in your C++ journey. So, welcome to ShivCore. As we say, master the core, build the future. So, let's begin. So, here, object-oriented programming in C++. From procedural programming to real-world software design. So it is one of the most transformative chapters in your journey. Till now you have written programs as collection of variables and functions. But this episode changes how you think. You will learn to model real-world entities using objects, the foundation of modern software design. So why OOP exists? Classes and objects, member, variable and function, constructor, deconstructor, access specifier, encapsulation, abstraction, inheritance, polymorphism, static members, friend functions, this pointer, real world hook design. So all of these are what you will master in this episode. So you are here at object oriented programming. Till now you have done a lot much in your C++ journey. And let me tell you, OOP is the foundation of modern C++ software development. So before diving in, let's understand the limitation of programming style we have been using and why a better approach is needed. So the problem with pre-procedural programming is that there are too many variables, too many functions, difficult to maintain, confusing code organization, and low scalability, and at the same time increased bugs. So if procedural programming becomes difficult for large software, can structure solve this problem completely? Let's find out. So did structure solve everything? In previous episode, we learned structure that can group related data together. A student structure hold name, roll number, and CGPA and branch all in one place. So structure solved one important problem, that is organizing related data, but another problem still remains. Let me know what is the problem before I get to explain that problem. So what structures fixed? Data that belong together is now grouped. Name, roll number, CGPA, all of it is inside one struct. No more scattered individual variables, cleaner and more logical data organization. But simply the other thing that what structure left unfixed was these functions that still exist separately from data, like display, update, search, calculate grade, they are all outside the structure. So here, as we know, structures organize data but not the behavior associated with that data. So how can we keep both data and the functions that use the data together? So that's exactly what object-oriented programming was designed to do. So why OOPS was introduced? Because programmers needed a better way to organize large software systems. The solution was elegant, so instead of keeping data and functions separate, it kept them together inside one logical unit. So every real-world object contains both information and actions. So programming should follow the same idea. Like if there is a car object, if there is student object, or if there is bank account object, so the data is given and the actions are there. Similarly, the data is given and actions are there, data is given, actions are there. But it requires better organization. Data and behavior live together in one unit. It requires better security because sensitive data can be hidden from outside access. Better maintainability, like changes that are localized, so less risk of breaking other parts. And better scalability, like easy to add new objects without rewriting everything. Or we can say better code reuse, so write once, reuse across the entire application. Or I can say easier teamwork, so different developers can own different objects. So OOP combines data and behavior into one organized unit. So let's formally understand what object-oriented programming actually means. So object-oriented programming is a programming paradigm that organizes software around objects instead of only functions and variables. And each object represents a real-world entity and contain both and contain both data and behavior. So objects communicate and work together to solve problems. So important thing to notice, OOP is not a new programming language. It's a different way of designing software. So a mindset shift from what does the programming do to what object exists in the problem. Let me tell you some OOP characteristics. They are modular, which means they're broken into self-contained objects. They can be broken into self-contained objects. They are reusable, means objects can be used across projects. They are scalable, easy to grow with new objects. Secure means data can be protected inside objects, and easy to maintain, that means changes are localized. So student object like properties with name, role, CGPA, actions like study and display required, or if a car object is there, then properties have brand and speed and fuel, but the action are required are state, start and break. Similarly for phone is call and charge. For bank account is deposit and withdrawal. So the thing that makes OOP so very powerful are its four core principles. Let me explain them to you. Very important diagram. The four pillars of OOPs. So every OOP language, including C++, is built around four fundamental concepts. These pillars work together to make software organized, secure, reusable, and scalable. So we will introduce each idea at a high level now. So each pillar will be studied in depth later in the episode. So encapsulation is the first one, which hides data inside objects, like expose only what is necessary and protects information like a locked vault. We can say abstraction, like hide implementation details, show only essential features, and like a car dashboard hiding the engine. The third one, inheritance, like create new classes by reusing existing ones. Child classes inherit parent behavior, saves time and reduces duplication. For the fourth one, polymorphism, like one interface, many different behaviors, same method, name, works differently for different objects, like a remote button that does different things on TV versus AC. So, some real world applications of object oriented programming, banking systems, hospital management, video games, e commerce platforms, mobile apps, social media platforms, ride-sharing apps, airplane reservation, like objects like flight, passengers, seat, booking payment, complex systems are made manageable through this. So, OOP mirrors how the real world is organized. So, how the object-oriented programming compare with procedural programming. So, let's put them side by side to know the difference. So, procedural programming and object-oriented programming. So both approaches solve programming problems, but they organize software very differently. Understanding their differences helps you choose the right tool for each project. Neither paradigm is universally better. OOP becomes especially advantageous as systems grow in size and complexity. Like for these categories, if program organization is function and variable grouped by task is done in procedural programming, whereas objects containing data and behavior together is done in OOP. The primary focus of procedural is that what the program does, and for OOP is what object exist and how they interact. Procedural has limited code reusability, but object-oriented programming has high. Data security has low, while for data security, procedural has low, but OOP has high. The scalability is difficult to gain for procedural programming, while it's excellent to do for object-oriented programming. So, similarly, maintenance is harder here and it's easier here. Real-world modeling is weak, here it's strong. Suitable project size is small to medium programs, but for OOP is medium to large and even complex systems. So, for this, team collaboration is harder because shared global state causes conflicts. But for OOP, it's easier because each developer can own separate objects. So, neither paradigm is universally better. Procedural programming is perfect suited for small, focused programs, while OOP shines when organization, maintenance, and reuse become critical. So, which is why it dominates modern software engineering. So, choose the right programming paradigm based on the problem you are solving. So everything in OOP begins with one fundamental concept, which is the class. So let's explore it next. So from real world objects to classes. So before writing our first class, let's understand the relationship between real world objects and programming. So in real world, every object has properties and actions. So in C++, we capture this idea using a class, a blueprint that describes what an object should contain and what it should be able to do so. Coming next, programming representation. Like class is used for blueprint, object is used for real instance. So here, some real world car like has properties brand, model, speed, fuel level, and its action should be start, stop, brake, and accelerate. So that's how this is. The real world object car with properties and actions has class blueprint to template defining structure and behavior, and has objects which creates multiple instances created from that blueprint only. So let me show you the first class program you are going to do. So coming to our VS Code, So taking return 0 here also, and after doing this, let me create a student S1 here. Below I will have S1.name, which will be equal to Rahul S1, and S1.age, which for now let me take 21. So firstly let me create the class student. Let me say class student. So here in this class student, I will say public string name int age, and this is the end of this. Coming next, coming next, we will simply say cout, and here I will say s1 dot name end of line cout s1 dot age end of line. So with this, our code is done. So when I run this, it simply gives s1 dot name and s1 dot age here, as according to I asked. So coming next, we have, one second, coming to our presentation. So understanding classes. A class is the blueprint or template used to create objects. It defines what data an object should store and what action it can perform. Think of it as a design document. It describes the shape, behavior of future objects, but does not store actual data itself. So a class is a user-defined data type that combines data member and member functions into single unit. So a structure stores related data while a class stores related data and related functions. So the architectural blueprint analogy captures this perfectly. So the blueprint is equal to class and the house is equal to object. So no memory is allocated until an object is actually created from the class. So coming next, class syntax and structure. I already did this. So C++ uses the class keyword to define custom data types. Each part of syntax has a specific purpose, and understanding them makes writing classes straightforward. So breaking it down, like class keyword declares a new user-defined type. Student class name, it identifies the blueprint type. Curly braces enclose all members of the class. Public access specifiers control visibility to members, and data members are variables storing object state, and semicolon is required at the end of class definition. Coming next, we have creating objects. Objects are real instances class created from a class. Each object gets its own independent copy of all data members, like using one cookie cutter to make many separate cookies. So, like student S1, student S2, student S3, student is the class blueprint, and S1, S2, S3 are objects, which are instances. So, key properties of objects are independent copies same class and different data, and they are scalable also. Coming next, accessing data members. So once objects are created, you use the dot operator to read or modify their data members. The dot operator is the doorway between an object and its stored values. So using dot operator like s1.name, s1.role, s1.cgpa, we do this work. So each object stores different value independently. But there are some common mistakes also, like forgetting the dot operator. So writing name equals to Rahul instead of you write name equals to Rahul, which is incorrect. You should write s1.name is equal to Rahul. This causes a compilation error. Or I can say accessing members before creating an object. So you must declare the object first. The blueprint alone holds no data to access. So confusing class name with object name. Like use the object variable example s1. So note the class name student when accessing members. Coming next, we have member functions. A class is not just for storing data, it can also contain functions that operate on that data. This keeps behavior and data together, producing cleaner and more maintainable code. Like display prints all data members of all the objects in a formatted way. Every object calls its own data. Like update CGPA modifies the CGPA value of a specific object and keeps data changes controlled and organized. Like calculate grade computes a letter grade based on CGPA. Logic lives inside the class where it belongs. So real life analogy, like a car doesn't just store fuel, it can start, stop, accelerate. So data and behavior belong together, and that is essence of class. Coming next, we have writing and calling member functions. So member functions are defined inside the class and called on individual objects using the dot operator. Each object runs the same function on its own unique data. So how the call works? Firstly, object is created like student s1, which allows memory for s1.data. Secondly, data is assigned. So here in data is assigned. So s1.name is equal to Rahul stores value in s1 only. Coming next, date function is called like s1.display runs on s1's data only. So that's important thing to note. Coming next, function output is produced. Function prints s1.name and roll number. So member functions are shared across all objects. Only one copy exists in memory, but each object passes its own data when called. Here is an complete example. I give you 2 minutes to understand it. I hope you understood it. Coming next, we have memory representation of objects. So understand how objects occupy memory is essential. So the class itself takes up no runtime memory, only the objects created from it do. So each object holds its own separate copy of every data member. Like the class blueprint, S1 object, S2 object, shared functions, separate data. Coming next, we have structure versus class. Both struct and class group related information in C++. The key practical difference is the default access level and how they are used in software design. Like in the category default access, data members, member functions, encapsulations, primary use, data security and flexibility, structures are public while class is private. For data members, structure is true and for class also it's true. Member functions are in structures and also in class. Encapsulation is partial in struct but fully in class. Similarly, primary use for hooks is for class is full, but for structure it's just simple data grouping. Rest you can also understand. Coming next, your first complete class program. So let's bring everything together: class definition, object creation, data assignment, member function and output in one complete working program. So go through this whole code. I am waiting for you. I am giving you roughly 2 to 3 minutes. I hope you understood it. Let me tell you what you have mastered till now. You have created classes, created objects, accessed members, and write and called functions. So, and also understand the memory. So you have officially written your first object-oriented program way before here in the episode. So coming up next, creating objects manually works. But what if every object could initialize itself automatically? So in the next session, we will discover constructor and deconstructor. So why do we need constructors? They create an object. Creating an object is easy, but assigning value manually every time quickly becomes repetitive and error prone. Imagine initializing 1,000 objects by hand. A big problem, but the solution is constructors. They automatically initialize objects and the movement they are created. The analogy here is like a new smartphone that runs its setup automatically on first boot. So constructor prepare an object before you start using it. So what is a constructor? A constructor is a special member function that runs automatically whenever an object is created. You never call it directly. The compiler invokes it for you. So key characters for it are same name as the class, no return type, not even void, called automatically on object creation, used for initialization of member variables. So let me show you an Visual Studio Code for default constructors. Yes, so here commenting all of this and coming next, firstly hashtag include, after this I will say a class student with the value of public here, and inside this public I will create a sub one where I will say its name as student, student, and I will say cout constructor called. After this end of line. So here it is, the code is done. Simply that's the end of this class student. After this I will simply say int main student s, and I believe that is pretty much it. Simply I will say when I run the code it simply says constructor called, and that's what we wanted. Coming back to our presentation, so default constructors, I explained you just now default constructor were those. So they take no arguments, like student was taken by my side. So and assign safe initial values to every newly created object automatically. So every student object starts with a defined safe state, no uninitialized memory. So why it matters is that never uninitialized safer program. So objects always hold valid default values, and safer programs like reduces bugs from garbage values. We can say predictable behavior. Every object starts from a known state. So think of a new notebook. It starts with blank pages before you write. So a default constructor creates a safe starting state. Next one for you, parameterized constructor. Not all objects should start the same. A parameter constructor just simply accepts arguments, so each object is initialized with its own unique data right from the start. Here you can see string n, int r, float c are parameterized constructor shown by the code. So how this generally works is object creation, constructor receives value, and members are initialized. Coming next, constructor overloading. So a class can define multiple constructors, each with a different parameter list. The compiler selects the right one based on arguments provided, giving you flexibly initialized options. So whether it's no argument, one argument, two argument, free argument. So one class can have multiple constructors with different parameter lists. A beginner mistake is never create two constructors with identical parameter list. The compiler cannot distinguish between them. Copy constructor. Sometimes you want to create a new object as an exact copy of existing one. The copy constructor handles them, duplicating all member values into a fresh independent object. Like syntax and example, here is the code and the key points used during initialization, copies all members values and creates a separate object. So copy constructor is a very important kind of constructor, and you can simply see how it works as a copy constructor here. Here student s2 is equal to s1 and this is where copy is created. Coming next, destructor. A very good one and very important. Every object has a life cycle. Just as constructor prepare an object, destructor clean it up automatically when its lifetime ends. This is destructor syntax. This sign with student, parentheses and curly brackets. So same name as the class, prefix with tilde, no return type, no parameters. So object lifecycle, object created, constructor runs, object used, destructor runs, lifetime ends. So let me show you a destructor code also in our VS Code screen now. So hashtag include IOStream using namespace standard int main. Here I am doing for in destructor code. Let me say a class demo here. Public now coming to the int main, we will simply say here demo d and now running the code it says constructor and destructor. So that's how I showed you with the demo that constructor and demo destructor are used after and then the code program ends. Commenting all of it. Now coming back to our presentation, like constructor versus destructor, I explained you also. These are the changes. Take a look at them, giving you 15 seconds. Done. So next, complete object lifecycle. So every object follows a predictable automatic lifecycle from creation through use of destruction. Understanding this flow makes oops far easier to reason about. Stage 1, class gets defined. Blueprint gets written by programmer. Stage 2, object created, memory allocated. Stage 3, constructor execute, automatic initialization. Stage 4, object used, member function called, data accessed. Stage 5, object lifetime ends, scope expires or delete code. Stage 6, destructor executes, automatic cleanup. And stage 7, program continues or ends, memory is fully released. So each stage happens automatically. The programmer focuses on logic, not manual memory management. Coming next, we have why do we need access specifiers. So far every member in our examples was freely accessible, but should everyone be allowed to change every piece of data? Imagine a bank account object. Should anyone be able to directly write account.balance is equal to 10 lakhs? Obviously not, I mean. So some information must be hidden from direct access and only authorized operations should be allowed. So not all data should be publicly accessible, and that's where we have this private work in object-oriented programming. So access specifiers in C++. They decide who can access the member of a class. C++ provides three levels of access control, each serving a distinct purpose in protecting and organizing your data. Please take a focus in this. Access specifiers available are public, private, and protected. So they are all inside class, yes. Outside class, they only public can be accessed, but not even private can be accessed and not protected. And for derived class, public and protected can be accessed, but not private. Private is only accessed inside class. So key observation, by default all members of class are private. So this is international C++ that encourages you to protect data first. So remember, access specifiers control visibility, not existence. So a private member still exists, it simply cannot reach directly from outside the class. So firstly, public members. Public members are accessible from anywhere. They form the interface between your object and outside world. Think of them as the reception desk of a college, open to all visitors, providing services to everyone. So, example student class. Common use cases here are display that shows object data, show details that print full info, and print result that outputs result. Here are some common mistakes like making all variable public defeats the purpose of OOP. So data should be protected, only behavior should be exposed. So this is an example of student class. I am giving you 2 minutes to read and understand this. I hope you understood this. It's public members where it's written public here, and all of it here is public to everyone. Next, private members and data hiding. Here you can see private is also there, public is also there, but private members cannot be accessed directly from outside the class. So only the class itself can read or modify its own private data. So this is the foundation of data hiding. Example, bank account. In a bank account, we have in private double balance because means it is hidden. Balance is hidden, so it cannot be accessed or changed normally. While as in public, we have balance plus equal to amount, which means we can deposit any time amount without any private and public issue. So why private? Because it prevents accidents, no accidental overrides, protects data, sensitive info stays safe. Reliability. Software behaves predictably. A real life analogy, your ATM pin is private. People can use the ATM, but they cannot directly read your pin. An interview tip for you is private data is one of the key ideas behind encapsulation, which is a very big and very important topic of OOPS. Coming next, getter and setter functions. So getter and setter functions, since private data cannot be accessed directly, we use special member functions to work with it safely. So getter returns value, setter updates value, but only after validation. So why use getter and setter? Because we have controlled access, the class controls every update, no wild assignments. We have data validation that reject negative balances or invalid marks before storing. We have better security. Sensitive data is never exposed without purpose. So here example is set balance and get balance are used in this code. Like here, set balance and get balance. Go through the code. I am giving you 2 minutes and then we will do the getter and setter function in VS Code also for better understanding. So I hope you have understood this. So now coming to our VS Code screen and we will try to do this code by ourselves also. So now So here I created a structure student. I will say string name int role and now and it and after it inside int main I will say student s3, which means we are having 3 students values. So we will simply take a for loop. We will say for int I equal to 0, I less than 3, I plus plus, and we will say user that to enter the name and here below I will take C in with S of I dot name. Simply I will take cout enter roll number and I will simply take C in S of I dot roll number dot roll. So after doing this, our for loop work is done. We will simply say cout. Outside the loop we will say cout slash n student details again slash n, and now below this we will take another for loop for I equal to 0, I less than 3, I plus plus cout, and inside cout is the main thing, which is S of I dot name and then these brackets, a space here, and then s dot S of I dot roll, and after this S of I dot roll we will simply say end of line, and that's it. Our code is done. So now when I run the code, wait, I will run again in new terminal. Yes. So running the code, here firstly it say ask for enter name. We'll say Rahul 101, Shivansh 102, Aryan 103. So it simply gives the student details as Rahul 101, Shivansh 102, Aryan 103. So that's how nicely it gives the output of complete structure, and that's so easy to do instead of writing 500 times. I hope you understood. So now So here I created a structure student. I will say string name, int role, and now end it, and after it inside int main I will say student s3, which means we are having 3 students values. So we will simply take a for loop. We will say for int I equal to 0, I less than 3, I plus plus, and we will say user that to enter the name and here below I will take C in with S of I dot name. Simply I will take cout enter roll number, and I will simply take C in S of I dot roll number dot roll. So after doing this, our for loop work is done. We will simply say cout. Outside the loop we will say cout slash n student details, again slash n, and now below this we will take another for loop for I equal to 0, I less than 3, I plus plus, cout, and inside cout is the main thing, which is S of I dot name, and then these brackets, a space here, and then S dot S of I dot roll, and after this S of I dot roll we will simply say end of line, and that's it. Our code is done. So now when I run the code, wait, I will run again in new terminal. Yes. So running the code, here firstly it asks for enter name. We'll say Rahul 101, Shivansh 102, Aryan 103. So it simply gives the student details as Rahul 101, Shivansh 102, Aryan 103. So that's how nicely it gives the output of complete structure, and that's so easy to do instead of writing 500 times. I hope you understood. So now So here I created a structure student. I will say string name, int role, and now end it, and after it inside int main I will say student s3, which means we are having 3 students values. So we will simply take a for loop. We will say for int I equal to 0, I less than 3, I plus plus, and we will say user that to enter the name, and here below I will take C in with S of I dot name. Simply I will take cout enter roll number, and I will simply take C in S of I dot roll number dot roll. So after doing this, our for loop work is done. We will simply say cout. Outside the loop we will say cout slash n student details, again slash n, and now below this we will take another for loop for I equal to 0, I less than 3, I plus plus, cout, and inside cout is the main thing, which is S of I dot name, and then these brackets, a space here, and then s dot S of I dot roll, and after this S of I dot roll we will simply say end of line, and that's it. Our code is done. So now when I run the code, wait, I will run again in new terminal. Yes. So running the code, here firstly it asks for enter name. We'll say Rahul 101, Shivansh 102, Aryan 103. So it simply gives the student details as Rahul 101, Shivansh 102, Aryan 103. So that's how nicely it gives the output of complete structure, and that's so easy to do instead of writing 500 times. I hope you understood. So now coming back to our presentation. So encapsulation encapsulation means encapsulation means wrapping data and the functions that operate on the data into a single unit while protecting the internal data from unauthorized access. It is achieved using classes and access specifiers. So private data like protected internal state and access control like restrict visibility and member functions like operate on the data are old comes inside encapsulation only. Coming next, abstraction. So next we have abstraction here. So abstraction means showing only the essential feature of an object while hiding the implementation details. So user interact with simple controls. So they don't need to understand when what happens underneath. Like ATM machine, you press buttons to withdraw cash. You don't need to know how the bank verifies your account or dispenses notes. Like car steering, you turn the wheel to steer. The complex mechanics of power steering and alignment are hidden from you. And TV remote, like you press a button to change the channel, the infrared signals and circuit logics are completely abstracted away. So encapsulation protects data while abstraction hides complexity. So this is the difference between encapsulation and abstraction. So these two concepts are closely related and often work together, but they solve different problems. So understanding the distinction is one of the most common OOP interview questions. For encapsulation, the purpose is to protect internal data, focus is data security and bundling, implementation is access specifier, real life example are capsule medicine. Similarly, and its primary goal is prevent unauthorized access and benefit is safer and more maintainable code. Whereas abstraction hides unnecessary complexity, focuses on amplifying user interaction, implements abstraction classes, interfaces and simplified APIs. Real life examples are ATM machines to press button and get cash. Primary goal is to reduce cognitive load and programming benefit is to easier to use and extend. Next we have real world example like secure bank account class. So this is the class diagram, private and public. So but students now understand that access specifiers public private protected. Here getters and setter are controlled and validated access. Data hiding is done through sensitive state which is protected. Encapsulation is data plus behavior bundled safety and abstraction is users see only what they need. So this is all of the content here. I'm giving you 2 minutes to read and understand it now. So I hope you understood the question. Now coming to the next slide. So why do we need inheritance? Imagine building school software, a student class and a teacher class both store name, date, age and ID. Rewriting these members in every class creates duplication, makes maintenance difficult and increases bugs. So inheritance solved this by letting one class reuse the property and functions of another. So just as a child inherits trait from a parent, a derived class inherits member from a base class. So it is helpful to reduce code and reuse code while also less repetition is done here, easier to maintain and better organization. So for you, I will explain this through VS Code also. So coming to our VS Code screen, hashtag include IOStream. This much is done. So I will be giving you an example of multi-level inheritance. So let me say here is a class named A, like this. It has a public in it. So inside public I will take a void loop named show A. So inside public show A, and inside this bracket I will say cout A/n. So that's it for this class A here. So therefore we have done one multi-level inheritance. Now I will make another class B, which is public to A. So here in this class, if I say public and I will say void show B. So inside this public void show B, I will say cout B/n. That's it. So for this, so after doing this, we will take another class C, which will public B. If you can understand. And inside this, I will say public void So here is cout C. So after taking here, let me remove /n here, and now I can take int main2 here. Make sure you are coding with me so that you understand more. I will say c dot obj and then cout, not cout. We will say obj dot show A obj show B obj dot show C here. Not C obj just. So I believe we are done with our code. Let me run this code. So we get A, B and C here. So that's why it is completely correct, and I hope you understood this code. It was a little bit tricky and it was not like that so much easy to understand. But if you understand it once, it's a very good topic, very important topic, and you all will like it. So single inheritance like name, age, ID. So inherits from derived class student, CGPA and branch. Similarly, type of inheritance in C++ is single, multi-level, multiple, hierarchical, hybrid. So I showed you just an example of multi-level inheritance in C++. So single inheritance is one derived from one base, student from person, used when there is a direct parent-child relationship. A chain of classes, multi-level is used when there is a chain of classes like person, student, graduate student. So used for tiered hierarchies. If there are multiple, means one class inherits from two bases, like teaching assistant from student and teacher. So used when combining two roles. Or we can say hierarchical, which means multiple classes inherit from one base, like car, bike, truck from vehicle, used for shared category siblings. Or we can say hybrid, combination of multiple types, diamond patterns, used for complex real-world systems, and may require virtual inheritance to resolve ambiguity. Function overriding. So sometimes a derived class needs a different implementation of an inherited function. So the function overriding lets the derived class provide its own version while keeping the same name and parameter list. Like a base class animal defines sound, a derived dog overrides sounds and returns bark, and derived cat overrides sounds and returns meow. So each class expresses its own identity. So common mistake here is overriding is often confused with overloading. So overriding is equal to same signature in a derived class, while overloading is equal to same name, different parameters in the same scope. So overriding allows derived classes to customize inherited behavior. Next we have what is polymorphism. So polymorphism form from Greek means many forms, means one inheritance can produce different behaviors depending on the object. The same function call behaves differently for different objects. Like one interface, many behaviors. For an animal, same animal is everywhere, but the small class of it, here is dog, here is cat, here is cow. So when the sound function is hit, so for dog it becomes bark, for cat it becomes meow, and for cow it becomes moo. So real life analogy, for one remote control operates different TV models, same button, different responses based on the device. So coming ahead, compile time versus runtime polymorphism. So polymorphism is classified into two categories based on when the decision about which function to call is made. So during compilation or during program execution, like features like mechanism when resolved, binding, inheritance required, performance and example. So for compile time, mechanism is to function overriding and operator overloading. For runtime it's function overriding but virtual functions also. Whereas compile time when resolved forms during compilation and in runtime it's during program execution. For binding it's early, it's late for runtime. For compile time no inheritance is required while for runtime it is required. Performance of compile time is slightly faster while runtime is small overhead An example for compile time is this void f int versus void f double, while as runtime is animal asterisk a is equal to no new dog parenthesis, whereas a refers to sound. An interview tip for all of you: student often confuses the two, so focus on when the decision is made and which feature enables it. Overloading, compile time, virtual plus overriding is equal to runtime. So compile time decisions happen before execution, runtime decisions happen while the program runs. So virtual functions. A virtual function allows the correct overridden function to be selected at runtime. So when a base class pointer refers to a derived class object, declaring the base function as virtual enables runtime polymorphism. Like declare virtual function, derived function runs, base pointer to derived. So function overloading versus function overriding, giving you 3 minutes, you can understand all of it waiting for you. I hope you understood it. Coming next, we have real-world OOP examples. So let's combine inheritance, overriding, virtual functions, and polymorphism into one cohesive design. A vehicle hierarchy that mirrors how professional C++ software is structured. A base class vehicle has members and virtual functions, and these are all derived class car, derived class bike, derived class truck, which are all comes under the base class vehicle. So this is inheritance example, a real world example for all of you. Coming next, the this pointer. Inside every non-static member function, C++ provides a hidden pointer called this, this. So it points to the object that called the function automatically without any manual setup. When two student objects both call display, this ensures each invocation accesses the correct object data. A static data member and static member functions. So static data member, one shared copy for the entire class. All objects read and write the same memory location. College name shared by all students. Tax rate shared across all invoices. And object counter tracking total instances. Static member function belongs to the class itself, not to any single object, can only access static members directly. So called without creating an object, used for global class level operations, memory efficient and no per object copy. Friend functions. Normally private members cannot be accessed outside the class, so the C++ allows trusted external function to bypass this restriction through friend functions. These are declared explicitly with the friend keyword. So the specialty here is not a member function of the class, can access private and protected members, must be explicitly declared inside the class. So when we can use friends function, when operator is overloading, utility function needing deep access, or closely related helper operations are required. But you have to use with caution. So friendship grants access, not ownership. So like a bank manager with access to secure areas, the ordinary customers cannot enter. Best practicing for writing hook code. So single responsibility, encapsulate data, inherit wisely, and write readable code. So mini project for all of you, giving you 2 minutes to understand this code, this question, and tell me the code in the comment section. I will tell it's right or wrong. And if there is any doubt you are having, please do tell me. Please, I request do tell me. I will make sure I will answer all of you. So giving you 1-2 minutes so that you can understand it. So I hope you understood the question. You have noted it. I make sure you try it. Some top interview and Viva questions for all of you. Like what is OOP? Classes versus objects, structure versus classes, encapsulation versus abstraction. So out of these 4 questions, how many you know? Just tell me right now in the comments. Say if one is correct, one you know, then say 1 by 4. Two you know, then 2 by 4. If you know the answer of 3, then 3 by 4. And if you know all of them, then say 4 by 4. And after that, say dot 1 for the first one. Similarly for dot 2 for the second one, dot 3 for third one, and dot 4 for fourth one. So constructor versus destructor, default versus parameterized constructor. So function overloading versus overriding, complete compile time versus runtime polymorphism, and why virtual functions. What is disk pointer? What are static members? And what is a friend function? So conceptual clarity creates confident interview answers. So draw a memory diagram or class diagram during explanation to stand out. A complete OOP mind map. Today we studied problem with procedural programming, need for OOP, classing and object, member variables and member functions, constructor and destructor, access specifier, inheritance, encapsulation, abstraction, polymorphism, this pointer, friend function, static members, and mini project for all of you. So your C++ journey so far, you have done foundations, control flow, data structures, functions, OOP. So now your ability is exceeded to a very good level where you are able to solve problems, you are able to think logically, your memory understanding is increasing and has increased a lot, and OOP design understanding is a very good and important topic, and that also you have mastered. So congratulations, you have successfully completed one of the most important topics in C++ object-oriented programming that powers desktop software, games, enterprise system, mobile development, and many more. So by mastering OOP, you have taken a major step toward becoming a professional C++ developer. So today you mastered all of these topics. So congo to all of you. Your homework for today is to complete the student management system, add teacher and course classes, implement inheritance where appropriate, practice interview questions, and revise the complete group mind map. So, up next, we are having the last episode of the series, which is file handling and STL. So, the part ahead is bright. Keep building, keep mastering, keep understanding. One thing for all of you, we have a website shivcore.bursal.app where we have all these notes and all available things that I have uploaded there. You can access them from there. So all I want to say is that master the core, build the future, and thank you for watching. Please do like, share and subscribe if you like the video, and do say to friends who require this. Your support means a lot to me. Thanks for watching. Bye bye. Signing off. ShivCore. Bye bye.